Hello, good evening, everyone. In this lecture, I'm going to take one question which is going to be based on 18.8 and 18.9 of Sydsaeter and Hammond. This question is based on Kuhn-Tucker theorem. And this is a short thing that is going to be definitely be asked in exam. So based on, constrained optimization, we want to go ahead and we want to see how to solve this kind of question. Please read the question, beta. The question is saying we want to go ahead and we are given a function, and the function given to us is 3x plus 4y. And we are given two constraints of this function, and the constraints of the function are x square plus y square less than equal to 4. So it is based on non-linear constraints of the function. And the second function given to us is minus x less than equal to minus 1. Your question is asking find the maximum value of the function. A question like this will be asked in exam. Very, very important from the point of view of your exam. Definitely it will be coming in the exam bit. Let's have a look. In such questions, wherever you are given non-linear constraint, how do we solve such questions? So you have to go ahead and you have to formulate the Lagrange. And in the Lagrange, you have to first write the objective function. So I have gone ahead and written this 3x plus 4y minus lambda 1. Lambda 1 is the first Lagrange multiplier. And then you have to write this constraint inside brackets. So I've written x square plus y square minus 4 minus lambda 2. Lambda 2 is the second constraint that I have written. And here you have to use the second constraint minus x plus 1. So this is my second constraint that I have used. Subject to the condition that lambda 1 and lambda 2 should be greater than 0. They cannot be negative. They have to be non-negative numbers. Now you will start solving using the Kuhn-Tucker condition. So the first thing that you will do is you will do partial differentiation with respect to x. So when I will differentiate this with respect to x, differentiation of 3x will be 3. Differentiation of x square will become 2x. And differentiation of minus x will become minus 1. So what will I get? I will get 3 minus lambda 1 into 2x minus lambda 2 into minus 1. So it will be plus lambda 2. That will be my first constraint that I will be, first partial derivative that I will be getting. But from here, I will just solve this first partial derivative. So I will get 3 minus 2 lambda 1x plus lambda 2 is equal to 0. This is my first condition that I have got. Then you will go ahead and you will differentiate this with respect to y. So with respect to y, माने बेटा यहाँ से you will get 4. Then here you see y square. Y square का differentiation will be 2y multiplied with minus lambda 1. So minus 2y lambda 1. And there is no y that I can see here. So is equal to 0. So the second constraint will give you then 4 is equal to 2 lambda 1 into y. And this will be your second constraint. After you have got the two constraints, next you have to write down the condition for complementary slackness. उसके बिना ये क्वेश्चन सॉल्व नहीं होते हैं. So then you have to write the condition for complementary slackness. The first condition for complementary slackness is that this part, ध्यान से समझो बेटा, this part has to be equated to 0. So I have written lambda 1 into x square plus y square minus 4 is equal to 0. But what is the meaning of complementary slackness? Complementary slackness ये बोलता है that if you meet, see the product of two things is 0. It means that one of them will be 0. either lambda 1 will be 0 or x square plus y square minus 4 will be 0. So complementary slackness says that if you are meeting this constraint with equality, matlab if you are meeting this constraint exactly equal to 4, then your lambda 1 will be positive. But if you are not meeting this constraint with equality, that means you have x square plus y square less than 4, then in that case, the value of the Lagrange multiplier will be equal to 0. So this is what is the implication of this complementary slackness, and we will be using this condition further. Similarly, you will be writing the next condition of complementary slackness, in which what you will do is you will say that this product is also equal to 0. So you will go ahead and you will say that lambda 2 into minus x plus 1 should also be equal to 0. Again, this complementary slackness will mean the same condition, bache, that when lambda 2 is 0, then minus x will be less than minus 1. And when lambda 2 will be positive, then this constraint will be met with equality. You will be meeting this constraint with equality. Now what you will be doing is you will be forming different cases. This is a full-fledged question, beta. Ye exam mein as it is aayega. So you have to understand this very carefully. So now you will start forming different cases. So case 1 that you will be forming is that both constraints are binding. Both constraints are binding. Both constraints binding का क्या मतलब है? Both constraints binding का ये मतलब हो गया कि देखो I am following them with equality. So x square plus y square भी equal to 4 है. The first constraint x square plus y square minus 4 is 0. So x square plus y square is equal to 4. Equality के साथ वो meet कर रहा है. And minus x is equal to minus 1. So minus x is equal to minus 1. Both constraints are binding. That is my first condition. Beta, when constraints are binding, जब हम constraints को equality के साथ follow करते हैं, तो जो Lagrange multiplier होता है, वो हमेशा it follows with greater than sign. So I should get the final answer where lambda 1 and lambda 2, they should be strictly greater than 0. This should be followed. This should be followed. ठीक है, let's see now. तो मैंने इस कंस्ट्रेंट को बाइंडिंग रख के बोला कि x square plus y square is equal to 4. एंड दूसरा कंस्ट्रेंट मेरा बाइंडिंग था, सो माइनस एक्स इज इक्वल टू माइनस 1 आया यहां से बच्चे. सो दिस मीन्स दैट x की वैल्यू आ गई 1. बेटा इफ x is 1, then I can put that x here. If I will put that x here, so I will get 1 square plus y square is equal to 4. So I will get y square is equal to 3. So I will get y is equal to plus minus root 3. ठीक है. सो आई हैव गॉट फाइनल वैल्यूज. जो मेरे पॉइंट्स आए वो आए हैं कि x is 1 and y is plus 3. This is plus root 3. This is my first point. And the second point that I have got is x is 1 and y is minus root 3. This is not the end of this solution. Many students will say कि these are my points. No, I have to check whether at these points my other conditions are satisfied or not. And what are my other conditions? That lambdas should be strictly greater than 0. That condition must be satisfied. ये check करना बहुत ही जरूरी है बेटा. So now what I will go do is I will go back to the two equations that I had formulated. And from here, bache, what do I see? I see that lambda 1 is 2 times 2 by y. Lambda 1 is 2 by y. So beta, tell me something. When y is minus root 3, y की दो values आई थी ना, plus root 3 minus root 3. When y is minus root 3, तो बेटा lambda 1 तो minus 2 by root 3 हो जाएगा, negative. So that case is eliminated. That is not possible. So the only case I am left to check is when y is positive. Now, if my y is plus root 3, so beta, what will be lambda 1? Lambda 1 will be 2 by root 3. And if lambda 1 is 2 by root 3, I will have to plug lambda 1 here to find out lambda 2. So I will get 3 minus 2. Lambda 1 का value आ गया बेटा 2 by root 3 into x का value था 1 plus lambda 2 equal to 0. So what will be the lambda 2 that I will be getting? I will get lambda 2 as 4 by root 3 minus 3. But this is negative. 4 by root 3 minus 3 is negative. So now lambda 2 is coming negative. So this is also not the right thing. I want both lambdas to be positive. So my complementary slackness condition is not being followed. So therefore I can say that this case 1 is eliminated. Both constraints are not binding. Pehla case eliminate ho gaya. You have to check 4 cases in total. This is a very tricky question and this is the kind of question that will be asked in exam. ठीक है बेटा, तो हमने ये पूरा अब check कर लिया. Now let's go to the remaining 3 cases. So what are the 4 cases we have? Both constraints binding. But when both constraints are binding, x square plus y square should be 4, x should be 1, lambda 1 should be positive and lambda 2 should be positive. ये condition eliminate हो गया. I have eliminated this case because I am getting either lambda 1 negative or lambda 2 negative. Then I will start with case number 2. But case 2 is one constrained binding. So now what I'm going to do ahead and say is that my first constraint is binding, but my second constraint is non-binding, right? So जहां पे तो binding है बच्चे, वहां पर my lambda 1 will be greater than 0. और जहां पे non-binding है, वहां पर lambda 2 will become equal to 0. Lambda 2 will become equal to 0 क्योंकि ये non-binding constraint है. Now you will go back to the 2 cases that you have formulated. तो वापस आप इसी condition पे आओगे. These are the 2 conditions that you have. और इन्हीं condition में आप अपनी values को plug in करोगे. Are you getting it? So now you have to again plug in these values and check. So what is the condition we have got? We have got that lambda 1 is non-zero and we have got that lambda 2 is 0. ये हमारी 2 conditions हमारे पास आ गई हैं. So बच्चे, if lambda 2 is 0, I will get 3 minus 2 lambda 1 into x is 0. And I have got 4 is equal to 2 lambda 1 into y. ठीक है. अब हमारे पास एक और कंडीशन हमारे पास क्लियर है कि बेटा x square plus y square is 4 because this is a binding constraint. So we have the condition that x square plus y square is equal to 4. So from here beta I will get that x will be 4 minus y square under root. And I will plug this x here. So I will get 3 minus 2 lambda 1, 4 minus y square under root is equal to 0. And from here, I know that 4 is equal to 2 lambda 1 into y. So I can solve for lambda 1. So this will cancel out and I will get lambda 1 as 2 by y. So lambda 1 की जगह पे I can plug this value of 2 by y. So what will I get beta? I will get 3 minus 2 into 2 by y. 4 minus y square under root is equal to 0. ठीक है. Just solve this equation. So I am just leaving it up to you. So I will give you the answer when you will solve this equation. Then beta you will get the value of y as plus minus 8 by 5. ये आंसर आपका y का आ जाएगा इसको solve करके. Now you have got y. you can get back lambda 1 from here. So when you will solve for lambda 1, right, using that equation, you will get 5/4. This is what we wanted. We wanted that lambda 1 should be positive. And we are getting lambda 1 to be positive, right? And we have got y as plus minus 8/5. So beta, what is x going to be? Using our constraint, x will be 3/2 lambda 1. yahin se aapka x ka value aa jayega. If I just go back to the constraint, just come back to this constraint. हाँ, so you can lambda 2 0 था तो यहाँ से हमारी x की वैल्यू आ गई थी ना बच्चे. We have already got x as 3/2 lambda 1. So you can just put the value of lambda 1 and get the value of x from here. So this is very, very, very important question. I'm again and again telling you. So when you will do that, you will get the value of x as 6/5. So we have got 2 candidate points now. देखो ध्यान से समझो इस केस में हमने क्या किया है. Try to understand. In this condition, we in the second case, we had to check that constraint 1 was binding and we had to check that constraint 2 was a slack. Constraint 1 binding का मतलब था कि x square plus y square equal to 4 होना चाहिए. मतलब lambda 1 should be greater than 0. और constraint 2 slack था. Slack मतलब कि minus x should be less than -1 आना चाहिए था and lambda 2 equal to 0 आना चाहिए था. Now, using these conditions, we found out कि जो y का वैल्यू आया है ना, y का वैल्यू आ गया है +-8/5 और x का जो वैल्यू आया है, x का वैल्यू I have got down as 6/5 and जो हमारा lambda 1 का वैल्यू आया है, lambda 1 का वैल्यू I have received as 5/4. So this constraint is satisfied, bacha. Lambda 1 is greater than 0 is satisfied and y is +-5, which is okay, fine. Y पे कोई constraint नहीं था. So we have satisfied all the properties that must be satisfied. So this condition is at this point where one constraint is binding. इस constraint को हमने binding रखा है. It is satisfying all possible conditions. So I have got 2 candidate points for myself. The first candidate point is when x is 6/5 and y is 8/5. And the second candidate point is when x is 6/5 and y is -8/5. Clear हुआ है? ठीक है बेटा. अब हम केस 3 लेंगे. So case number 3. Beta, case 3 will be when the first constraint is non-binding and the second constraint is binding. तो हमने लिया x square plus y square को less than 4, यानी कि lambda 1 equal to 0 हो गया. And second हमने लिया -x को binding और यानी कि lambda 2 जो है वो positive हो गया. ये मेरा next constraint conditions आ गई. You have to check all permutation and combination in exam. ठीक है बेटा. Now I am taking this case where lambda 1 is 0. So if I just go back again to my equations that I had created and I take lambda 1 as 0, what will I go ahead and get? Let's quickly check that out. So from here, it will mean that 4 is equal to 2. Lambda 1 का value 0 लिया है into y. So 4 is equal to 0. This is a contradiction. So it is not possible. It's a contradiction. So 4 cannot be equal to 0. So which means that this permutation combination is incorrect and this is not possible. So where have I written that? So this is also not possible. This is incorrect. अब हम last case लेंगे बच्चा. So case number 4. I hope all of you have done these kind of questions. Very important from exam point of view. So, but case 4 will be when both constraints are unbinding. So, x square plus y square is less than 4 and minus x is less than -1. It means both the Lagrange multipliers will be equal to 0. But beta जब Lagrange multiplier 1 ही 0 था, I have got a contradiction. तो अगर दोनों भी 0 हो जाएंगे तो भी तो contradiction ही रहेगा, क्योंकि वो वाला contradiction तो अभी भी है ही. So this is also not possible. So we have checked all permutation and combination and we have got that constraint 4, मतलब case 4 ठीक नहीं है, case 3 भी ठीक नहीं है, case 1 भी ठीक नहीं था, and there is only one case which is correct where we got that only one of the constraint is binding और यहाँ से हमारे पास 2 candidate points release हो गए हैं. So now I just have to check the value of the function at these candidate points. तो इन कैंडिडेट पॉइंट्स पे पहला कैंडिडेट पॉइंट आया 6/5, 8/5. इस पे मैंने फंक्शन की वैल्यू चेक कर ली. सो माय फंक्शन वाज 3x + 4y. So when I plug x as 6/5 and y as 8/5, I get the value as 10. And the second candidate point is 6/5, -8/5. And when I plug in that, I get the answer as -14/5. So clearly this is more. So finally, I get the point of maxima as 6/5, 8/5. And this is the final answer to this question. Very important question, beta. This will come in exam. The Kuhn-Tucker question will come in exam as the highest marking question. It can come as a 15 marker in exam in which you have to evaluate all possible conditions. So इसमें आपको पहले Lagrange form करना होगा, then आपको partial derivatives निकालने होंगे, then you have to check the complementary slackness condition, and then you have to form all possible cases like I formed in this example, and from there you have to check where in the different candidate points you get a maxima or minima. This is a full-fledged question that will be asked in exam. Okay, beta? Okay, thank you.